Okay, we're going to continue right now um, with the exponential growth, and we're going to try to fit an exponential function. We're going to look at the growth of New York City early on and later on to see where exponentials start correctly and then do poorly. We're going to work through something that we're going to work through a couple times, which is grabbing web data, just so we sort of hammer that home. We're going to click on the plus here to add a new sheet. We're going to go to data. We're going to do from web. And we're going to paste the URL, which you can get from Moodle, or you could Google it, but it's on Moodle. And um, so this is the raw.github, NY Times, blah, 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 blah. You can see it. And that's it. We're going to say OK. And it takes a minute. And it pops up and gives us this, so we make sure what we have. So we have cases and deaths everywhere in the country. So we're going to load this, and it spins for a little bit. It might spin for a long time for you depending on your internet connection, but it went fairly quickly for me. And so we have all of these cases, but what we'd really like is we'd really like New York City over time, and these are set to filter, right? So we're going to click right here on the county, and in the search bar we're going to type in NEW for New York, and we're going to select none, and then we're going to click New York City. So this grabs all of our New York cities, and it has the cases and deaths throughout the entire time. So this is a lovely thing that we're going to fit. We're going to do a Control A to select it, a Control C to copy it, and then we're going to paste that into a new sheet with a Control V or a paste. So now we have it. We have our date. We have our FIPS, our New York City. Notice it doesn't have a FIPS. And this is all 5 boroughs. Later on we'll show you how to get the data to split that. But what I'm going to do right now is I'm going to click on E and insert. And then I'm going to put my day in here. And we learned how to do that. It's going to equal, well, it's going to be day 1 here, first case, and it's going to equal day 1 plus 1. And then we're going to copy that on down. All right, so we're just going to graph the first, first 30 days. How does that sound? So we're going to select day and the first 30 days. We could do this with the dates, but we're just going to use the numbers to 31 to give ourselves sort of what was happening. And we were starting to get fairly caught up in this sort of thing. Actually, let's do the first 17 days and see where we were in the first 17 days, because this was the period during which Mayor de Blasio, and Governor Cuomo were arguing about whether they should shut the city down or not. So we're going to have those selected, and we're going to insert, and we're going to do a chart, and we're going to do our growth chart here. And so there we go. It's grown pretty fast, looks sort of exponential. And we have cases, and we could double click on that and do coronavirus cases. Corona, can I type? Virus cases in NYC. Could have put New York City. And so there we go. Looks sort of exponential. It's going up. So we're going to click on that. Right click. We'll add our trend line. We'll make it exponential and display the equation and the R square. Wow. Will you look at that? Almost a perfect fit. We'll talk about what R square means here in just a minute. So I'm going to check how much time we've got because I don't want to go too long. We're only at 4 minutes, so good. We still have some time to do that. So this is the estimates that we were seeing before. And it looks like this thing could have, with those kind of estimates, note the growth rate is faster than we had in our previous model on sheet 1. It's the 0.4 is faster. We had 0.21. So it appeared it was growing much faster than the 3 cases in 14 days. It looks like the spread was faster, and that's partly because more people were getting tested, and it had been spreading for longer than that. So it was pretty super duper hyper exponential. Um, at that point, well, it was exponential at that point, and that 0.9936, that's an almost perfect fit. So statisticians would have sort of been going nuts at the level of that fit, and then we should be able to take that function and predict out many, many, many days. So what I'm going to do is I'm going to select this function here, and I'm going to create a new sheet here, and I'm just going to paste my function over here, and I'm going to do day and cases and 1 and drag this down to 60-ish, 70-ish cases. And then I'm going to put in my formula here. It's going to equal 4.4709 times the day I'm sorry, times EXP of 0.4345 times the day. And then we're going to finish our parentheses. And so that was slightly less than a case in the first day, slightly more in the second day. And then this runs on down to millions of cases within 2 months. If we follow this model, we can go ahead and go down, and through 17 it would look fairly similar. We know that, but we're going to broadcast out to 40 days, and we're going to insert our chart. And there we go. That, of course, should have a perfect fit on it, but this is what we do. This is the predicted cases, which we just did from the equation. We add our trend line, we make it exponential, it better fit it perfectly, and then we add our r square and our equation back on, and it, of course, gives us back our equation. So that's it. We took and we estimated an exponential function from the data for New York City, and then we predicted out from 17 days to 40 days, and that gave us insane numbers of cases. So, but people knew it really wasn't going to get to 2 or 3 million in New York City, but at that point in time, people were saying things like 215,000, 315,000. That's largely where we've gotten, because we think these things flatten out, and we'll get into logistic models very, very quickly. But I just wanted to show you this estimation procedure and how we do that very quickly in Excel, just using the curve fit functions, the trendline function, which gives us what we needed to do exponential prediction. Now, clearly, exponential prediction is off. It's pretty good early on, but once you get out, and the complexities of the disease and people being immune, and the first people spreading around tending to have higher spread rates, and all of that, all the complexities of epidemics, we're not going to have those kinds of growth, but at least early on we expect exponential growth. And in fact, like I said, we very much saw it. So, and it was even faster than the 3 contacts per, or three people infected per infected person. Of course, this is New York City, where people aren't getting on a public transportation with 75 other people in a contact in any bus ride or any subway ride. So it's different.